Tesla has finally introduced its aluminum-ion battery in the 2026 Model 2, a move that could reshape how we think about electric cars. While headlines claim this technology will end the lithium era, the real story lies in how it tackles two major challenges. First, it offers a practical path for retrofitting older Teslas, addressing the fear of obsolescence that has troubled owners for years. Second, it is being rolled out in a way that avoids overwhelming America's already fragile power grid. Tesla owners have long worried about what happens when new battery technology arrives. Current lithium packs are glued in place, designed with specific cooling systems and battery management software. If a better chemistry appears, swapping it into an older car has seemed nearly impossible without replacing the entire vehicle. A Model 3 from 2020, for instance, was built around a lithium pack that cannot simply be exchanged for something new. That has left many owners fearing their cars could become outdated and lose value. Tesla's solution comes through something called the Cross-Platform Module Interface, or CPMI. Internal documents suggest this design allows batteries to be modular and interchangeable across different models. Instead of being welded into the structure, the new aluminum-ion pack is built as a drop-in module. It matches the size, weight, and mounting positions used in the Model 3 and Model Y, built after 2021. By standardizing these design details across factories in Fremont, Austin, and Shanghai, Tesla quietly prepared the ground for retrofits years in advance. The result is a system where technicians can remove an old pack and replace it with a new one without cutting, welding, or voiding warranties. Owners could keep their existing vehicles while accessing the latest range and charging improvements. Paying $5,000 for a new pack is far more appealing than spending $30,000 or more on a new car. Physical fit is only half the battle. Aluminum-ion cells operate at about 20 volts per cell, far higher than the 3.8 volts produced by lithium-ion cells. Putting such a pack into an older vehicle without adaptation would cause instant failure. Tesla addressed this problem through a multi-chemistry battery management system that can read voltage and temperature from each module and adjust the car's inverter in real time. This system makes it possible for different battery chemistries to operate within the same car. Tesla can even deliver compatibility through software updates, giving older cars the electronic intelligence to use the new pack. This flexibility is unique to Tesla, since few competitors have invested in this level of software integration. Aluminum-ion batteries carry far more energy than lithium packs, which raises risks of overheating. To counter this, Tesla designed the CPMI sled with liquid microchannels under each module, spreading heat like a high-performance computer cooling system. Active heat pipes add another layer of control, keeping temperatures under 113 degrees Fahrenheit even during rapid charging. This allows aluminum-ion packs to charge at up to 6 times today's fast-charging currents without overheating. For owners, this means charging to 80% in under 6 minutes while keeping safety concerns in check. The combination of higher range, faster charging, and reliable safety systems makes the new pack a major step forward. Industry estimates suggest a 60 kilowatt-hour aluminum-ion pack could provide about 1,000 miles of driving range for around $5,000 installed. Compared to the expense of buying a new Tesla Model 2, which would likely exceed $30,000 once taxes and fees are included, the retrofit offers huge savings. Owners also avoid the hassle of financing, insurance changes, or learning a new car. Emotional attachment plays a role too. Drivers can keep the cars they already know and trust while upgrading their capabilities. At first glance, retrofitting older cars might seem to undermine Tesla's new car sales, but it actually supports the company's larger goals. Retrofits bring in high-margin revenue without the costs of manufacturing new chassis or shipping entire vehicles. They also keep customers loyal, preventing them from switching to competitors. In effect, Tesla is turning cars into platforms that can be updated over time, similar to how smartphones receive software upgrades. If 1 million US Tesla owners paid $5,000 each for a retrofit, the company would generate $5 billion in revenue with minimal overhead. Reports suggest Tesla will launch an official retrofit program for cars built in 2020 or later, requiring inspections and installation at certified service centers. The program is expected to start 6 to 12 months after the Model 2 reaches the market, balancing the need for new car sales with the promise of upgrades. Faster charging naturally raises worries about whether the power grid can handle the demand. The US grid has already struggled under extreme conditions. In Texas, for example, heat waves in 2023 and 2024 pushed demand past record highs, forcing conservation alerts. The idea of millions of Teslas suddenly pulling several times more power sounds risky. Tesla has planned for this by designing its supercharger rollout around buffering and load shifting. Each new charging station includes megapacks, large on-site batteries that store 3.9 megawatt-hours of energy and deliver more than 1.5 megawatts continuously. These units charge overnight when grid demand and electricity prices are low, then release energy during the day as cars arrive. This means drivers pulling in for a 5-minute ultra-fast charge are often drawing power from a megapack, not directly from the grid. Most Tesla charging still happens at home, and the aluminum-ion battery is designed to make this process smooth. A typical 40-mile commute uses about 10 kilowatt-hours of energy, which can be replenished overnight with a standard 240-volt charger. Tesla's time-of-use software schedules charging during off-peak hours, usually between 2 and 5 a.m., when rates are cheaper and demand is lower. Even more transformative is the potential for vehicle-to-grid integration. An 80 kilowatt-hour Tesla pack could power an average American home for nearly 3 days. If 1 million owners participated, they would provide 80 gigawatt-hours of buffer capacity, equivalent to the output of about 50 small coal plants. This would not drain the grid, but instead help stabilize it, especially during peak hours. Utilities in California and Texas are already testing these programs, showing that electric cars can support neighborhoods during shortages. The arrival of the aluminum-ion battery represents more than just technical progress. It changes how we think about cars. Instead of vehicles becoming outdated as new technology appears, Teslas could remain relevant through modular upgrades. Instead of straining the grid, they could become part of the solution by storing and sharing energy. The challenge now is how Tesla balances retrofits with new sales. The most likely scenario is that retrofits will be offered for newer models first, while older cars may not qualify. For millions of Tesla owners, though, this marks the beginning of a future where their investment can grow with technology instead of being left behind. The aluminum-ion era could transform everything we know about EVs, from retrofits to powering the grid. Do you see this as the future of car ownership, or just another promise? Share your thoughts below. We'd love to hear how you'd use this technology in your own life.